Hi, my name's Andy, and this is my YouTube channel, The Odd Inventor, where I work on interesting and sometimes odd side projects. Let's see what I'm working on today. I'm starting to take a lot more video, and when I do, I've realized that my phone starts to overheat. I'm using a Pixel 2, and with some research online, I've found out that I'm not the only one that experiences this problem. As a matter of fact, when taking HD video, most phones do tend to overheat after recording for a period of time. So I started looking into options. I currently use a tripod mount with my phone. This is a 3D printed case that I found on Thingiverse, and I made a tripod bracket adapter here. And this works fine, except for it does not keep the phone cool. Even though there's all these holes, it does not do the job. So I looked into passive cooling with just something like a heatsink that I pulled off of a motherboard of a computer, and 3D printed another model that had to extend it out a little bit further so that the tripod mount, when the heatsink was in there, was able to fit in without hitting any of the tripod brackets. And while this worked for a while, the phone still got too hot and overheated. The nice thing is that the heatsink was also warm. So it was doing its job, it just wasn't able to remove enough heat. There is always the option of adding a fan to it. As a matter of fact, I pulled a fan off of this heatsink. But the problem with that is when I have a fan running while I'm also recording video, you get a lot of background noise. So now we're on to the third iteration of what I've been working on. This is a large heatsink, the size that fits this hole. The one I was showing you is a little bit smaller. And it is epoxied into the case. I've built an enclosure around the heatsink itself, and these are now two water cooling lines with a garden hose attached to it. I need to pull this apart because while this is my first iteration of the design, it works, it leaks a lot. Now the Pixel 2 is water resistant, 1 meter for a half an hour, but I would like to not submerge my phone in water while recording videos. So we're gonna have to look at changing the 3D print and making it more waterproof, re-epoxying in the heatsink, and then testing it out. Stay tuned. Here's the model that I've been working with. As you can see, I'm using 3D Builder, which is an app made by Microsoft. It comes with Windows 10 for free on the Microsoft Store. I know a lot of people use Fusion 360, but I've found that 3D Builder gives you enough primitives and easy to use features, including good touch support, to be able to accomplish most tasks. The old model leaked bad. So here I am checking the model using X-ray view in 3D Builder to see if I've left any gaps or openings along any of the inlets or outlets. Interestingly enough, I'm not finding anything out of the ordinary. Everything looks like it's connecting. Everything seems like it's fitted well. So instead I figured that I would just tighten some of the metrics a little bit and have more overlap. My 3D printer is a Lulzbot Mini. So here you can see I'm using the Kira Lulzbot edition. And what I'm doing is I'm looking at the 3D printing path to ensure that the slicer is covering all the areas that I'm expecting it to. Just again, looking for any obvious leaks. With that out of the way, we can start the 3D print. I had to restart this print 3 times because it was not adhering to the bed properly in some of the hard to reach places. No fault of the printer, it's just a very difficult model. In all total, on fine print settings, this print took about 12 hours to complete. It's the next day and my 3D print completed overnight. So let's peel it off and see what it looks like. First impressions are quite promising. Now this is the Haze PLA, just uncolored. And after stopping and restarting this print and adjusting some things several times, the main deal is these hose connects right here. They were not, this one was not forming properly normally on the start of the print, going from the bottom up. And if they don't start properly and adhere to the bed, it will almost certainly never complete properly. This is on fine print settings, so that's why it took 12 hours. If I did standard print, the estimated time was 7 hours. And let's get the support material off of here. Got plastic dust all over the place. I'm gonna have to vacuum in here. This one's gonna work way better. I'm excited. These turned out really well. So now the hope is we'll be able to take the water line, fit it around here, and then hose clamp it on. I'm not forcing it too bad because I'm worried about how brittle this is. What I'm gonna do is I'll heat up the hose line so that it's a bit more flexible, and then squeeze it on there. Our next step though will be to epoxy our heatsink into the case. Put an epoxy bead right on this perimeter to seal it up for any water, and that way water will flow through the system and transfer heat out. Before I start epoxying this in, I've noticed that there's a little bit of a bump on this side, maybe on both sides of the heatsink. So what I'm going to do is I'm going to take a Dremel and grind this middle bar down a little bit, because this middle bar is what fits through this slot and holds it up from the bottom of this pocket. I don't like the angle that that spit is going in at, so I'm going to switch it to something else. Now this grinding bit is probably not meant for this kind of material, but it's the right size and it'll work. The trouble with grinding this stuff is that you actually end up heating it up, which then softens it, which then can make it gummy on the grinding wheel and can also distort the shape. The nice thing about this support beam is that it's just kind of a guiding point. You don't actually have to worry about it being structurally important, as now I've taken down enough where it's starting to warp it a little bit. Hopefully I won't have to 3D print another one of these cooler cases, but if I do, note to self that I will make this cross beam go down a little bit further. That's better. Now just mixing up our epoxy. We have to move quick because there's like a 5-minute set time for this. And we get our heatsink in there and centered and even on both sides. And now we can start applying the epoxy. I'm just checking now for any holes or pockets. There's a little bit of a divot right here. Looking at the mirror finish here of the surface of the epoxy, I can tell where any pockets or holes are. I've filled most of them up, most all of them I believe. So now we just have to wait for it to cure. And then we can take that bump edge off. It's now the next day. The epoxy has fully cured. You can see there's a bit of a bump along this heat sink around here. We'll take that off with a Dremel and then test it. This is looking pretty good. Let's hook up some hoses to it and see if it holds water. The cool thing about this semi-transparent plastic is you can see the heatsink inside, and you can see how much tolerance I have. See about hooking up one of these, and then I need the other one. To help get these on, I'm going to heat up this plastic here. And then let's do the same for the other side. Notice I'm not holding the flame directly on the plastic. I'm just kind of waving it past, licking it. I don't want the tube to burn. I just want it to get hot, and exposing it directly to the flame for a long period of time will make it catch fire, and I don't want that. See how easy that slides on there now? Okay, these are both snugged on there. Nothing's cracking, popping, shifting, shaking. All right, let's get the rig set up and test it out. We're just about ready to start the water cooling test. But before we start, one thing about water pumps is that most need to be primed before you start them. So what I'm doing here is taking a cup of water and putting it into the inlet of the hose. The reason why is because the water pumps are designed to exclusively pump water, and without the water lubricating the pump, you can burn it out. All right, let's fire it up and see what it does. You can see the bubbles coming out of the hose. Okay, we do have water leaking out of the system. It looks like there's a small hole in the 3D print causing a leak out, either the sidewall or the tube that leads down out here. We'll shut this off and try and seal it up with either heating it up or an epoxy or potentially hot glue. I've taken the water cooler back to my workbench, and I've sealed off this end of the hose with a plug. So that lets me blow air into this end of the hose, and then I can see where any leaks might be. I've got a water bottle here to squirt some water on it. So I'll be able to see where the water is leaking out of the system. So that's where it's leaking. At least one of the leaks is right here. This is probably a model defect that wasn't sealed up entirely. So I've got a couple of these plastic strips, prints that I had to stop early on, but I'm going to hopefully cut a section off of this. And I'm going to use my soldering iron and remelt some of this plastic to try and fill the hole. Still a no-go. All right, let's just fill it up with hot glue all in here. We have to dry it out pretty good first, and then we'll just fill it up with hot glue. Here's test 2 after putting a whole lot of hot glue onto the case to try and waterproof it as much as we could. I believe this is about as far as we can waterproof it before we're gonna have to try alternative methods. Here we go. Using a second cell phone with an infrared camera, I'm able to check the temperature of my Pixel 2 as it's recording this video. And it looks like it's at about 47 degrees Celsius. Let's see if we can cool down our phone. It's still leaking a little bit, but a lot better than before. Here's how bad the dripping is now after all the water sealing. Not too bad. Not the best, but also not bad. This is probably the least amount of dripping that I've had so far of all the case designs. And it seems to be working pretty good. I'm going to call that a win. In looking at a couple of the different infrared shots from the thermal camera, you can see that the top part of the phone is at 46 degrees, whereas the cooler part of the phone is about 34 and the middle range is sitting at about 36, which is a vast improvement from the 47 across the whole phone, at which point, coincidentally enough, the phone did shut down due to heat. Looking at the back of the phone case, you can see that the water that's circulating through it is around 12 degrees Celsius, or about 53 degrees Fahrenheit. And this is doing a pretty good job at keeping the phone from overheating. So that concludes this video of the Pixel 2 water-cooled phone case. If you'd like to try to make this 3D model for yourself, I'll upload it to Thingiverse and put a link in the description below. It works pretty well. I was able to record HD video continuously with the phone in the sun without it overheating. So it's doing a job. Before I plan on using this full time to record my videos, I'd like to improve the water tightness of the case, beef up some of the 3D print walls so that there isn't a chance of it leaking through, maybe experiment around with full infill for some of the structures so that there isn't any webbing on the inside, it's just solid plastic throughout. And then extend some of these hose lines so that I can run this water cooler from longer distances. So I can have the pump outside or far away where you can't hear it, and then have this hooked up to my tripod, recording on my workbench, and have it continuously be cooled. If you're interested in follow-ups on this, leave comments in the section below. Otherwise, if you enjoyed this video and would like to see more, please subscribe. Thanks for watching.